Hey everybody, it is now time for some kitchen science. Oh yeah. So let's go ahead and introduce this topic so that we can go ahead and get started on this because it's this week I'm going to have to really condense it down to try to stay in our time frames. So the first thing we're going to look at is look at a little review of what we did last week. So as you can see, chem4kids.com. So we're talking about uh, the first thing we looked at was our atoms. Remember that we went through atoms last week, and we had the first thing was the electrons, protons, and neutrons. We did the experiment on my ceiling fan, which is over there. And we put the balloons up, we put the ping pong balls up. You saw that the neutrons, the protons were in there in the center, in the nucleus, and then on the outside was your electrons. Now, the next after that, we looked at the actual elements. Now, elements were made up of atoms. So atoms are made up of electrons, neutrons, and neutrons, protons, electrons. So those are all the same. It's just how many you have to make whatever molecule it is. Next, you guys got the actual elements. The elements are made up of those atoms. Then your molecules are made up of those elements. So we're building on it. So we went from the subatomic particles to the atoms to molecules of elements. So we're building up. Now we're talking about the states of matter. So the way that these elements are either combined or the way that they appear to you in real life. So now we're getting to the actual what you can see when it comes to science. So there we go. And last week we made water, peroxide, glucose, and propane. We made those with the starburst jelly beans and toothpicks. But if you haven't done that activity yet, please go back to week 1 science so that you can do that, because right now we're going to build on top of that. So as we're going to go in, I know it seems a little bit counterintuitive that we went from atoms to elements to periodic table back to matter, but it's easier to do it from a micro level to a macro level so that you go up in layers. So as we're talking about matter, this week we're talking about matter. Now, when we're looking at matter, there are multiple types. Like there's multiple ways matter can be in the world. Now, I keep looking over to my to my stove because I started my experiment already. And I'm going to go ahead and pause this video for just 1 second. I'm going to go and turn that off because I didn't realize how fast that was. Okay, I'm back. It took me a second. I was pretty sure that was going to probably explode. So the matter is the stuff that's all around you. Okay, so let's go ahead and read a little bit about this so that we can get an idea of what we're talking about when it comes to matter. And then we'll go ahead into the different states of matter. And don't touch your face. I know I keep touching it. And I put the bandana on today. I'm going to start wearing the bandana because I need a haircut because everybody shut down, so I don't have much of a choice. So what I'm going to do is I'm going to put my bandana on to keep my hair back so I stop playing with my hair. All right, going up, and as we're following along, what is matter? Matter is everything around you. Atoms and compounds are all made of very small parts of matter. These atoms go on to build things you see and touch every day. Matter is defined as anything that has mass and takes up space. What is mass? Mass is the amount of matter in an object. You might have a small object with a lot of mass, such as a statue of lead. You might have a large object with very little mass, like a balloon filled with helium. So as you can see, we learned from last week. We're going to pause real quick on the reading. Lead is a metal, and when you put that in your hand, it's extra heavy. Okay, but if you put a balloon in your hand, it's light. So you might have a little tiny piece of metal, which is heavy, and then a balloon, which is pretty big comparatively, that is light. So the mass is different on the two objects. It doesn't matter how big or small something is, how much stuff is shoved in there, and we'll look at that in a minute. You should know the difference between mass and weight. Mass is the measure of matter in the object, while weight is the measure of gravity on the pole. And we'll talk about the weight of something later, because that is those two they're key terms, but for this discussion, it's not as important. What is volume? Volume is the amount of space something occupies. Words such as big, little, long, or short are used to describe volumes. A marble takes up a volume while a star occupies a large volume. So a marble's little, small volume. Like a star is ginormous, so it takes a lot of volume. Different states of matter will fill volumes in different ways, and that's what we're going to look at this week, at least a little bit. Even though matter can be found all over the universe, you will only find it in a few forms or states on Earth. We will cover 5 states of matter on the site. We're not going to go into all 5 of them because plasma, listen, we're doing this in my kitchen. I'm not making plasma. I am absolutely under no circumstances making plasma. And when it comes to dropping somebody, taking enough heat out of something where it's almost at absolute zero, I can't do that either. At least not with the equipment I have at home, or safely for that matter. All right, so each of the states is sometimes called a phase. And we're going to talk about phases. There are probably many other states of matter that exist in extreme environments. I do not have coronavirus, by the way, not yet anyway. Scientists will probably discover more states of matter as we continue to explore the universe. So this is the 5 states right now. So you have these Be condensates. Now, these ones here, like I said, you got to drop the temperature of these of this matter so far that it gets a state that is almost like where the molecules are frozen, like frozen. I'm talking like the actual electrons and stuff. So we're not going to do that. Solids. We will be discussing solids. Liquids is where we're at this week. Okay, I spent quite a few hours on a liquid lab for you this week, and I did it because number one, it was fun for me, and second, I really enjoyed it, and I saw it and I wanted to do it, so we're doing it. Gases is something we will go over just a little bit because it's a little bit more confusing unless I'm there with you. And when, like I said, plasmas, I don't want to burn my apartment down, so we're not playing with plasma. All right, everyone should know about liquids, solids, liquids, gases, and plasmas. Scientists have always known about liquids, solids, and gases. Plasma was a new idea when it was identified by William Crookes in 1879. We would also like to talk about the Bose-Einstein Condensate, the BEC. It's a fun state of matter which you move almost all energy from the system. The scientists Cornell, Ketterle, and Weiland, who worked with the Bose-Einstein Condensate, received the Nobel Prize for their work in 2001. What makes a state of matter? It's all about the physical state and energy in the atoms and molecules. Think about solids. Physical properties of a solid include hard or brittle. This, as you all are aware, is my absolutely spectacularly amazing coffee cup. This is a solid. Okay? Solid. Keeps its shape when I'm touching it. Inside, on the other hand, is a liquid. The liquid conforms to the inside of my cup. You don't see liquid way up here and no liquid down here. Okay? You have liquid. Most liquid will settle into a container, and it usually has to be held by a container, and that's going to be important later. All right. So here we go. Liquids are fluidy, move around a little and fill up the containers. Gases are always around you, but molecules of gas are much further apart than molecules in a liquid. If a gas has an odor, you'll often be able to smell it before you can see it. The BEC is all about atoms that are closer and less energetic than atoms in a solid. Okay, changing states of matter. We will be doing this in tomorrow's video. And we're going to do the physical change between water as a solid, water as a liquid, and water as a gas. Okay, so we're going to be looking at that. What is a physical change in matter? Molecules can move from one physical state to another, a phase change, and not change their atomic structure. Oxygen gas has the same chemical properties as liquid oxygen. The liquid state is colder and denser, which is less energy. But the two molecules are the same. Water is another example. A water molecule is made up of 2 hydrogen and 1 oxygen atom. We looked at that last week. It has the same molecular structure, whether it is a gas, liquid, or solid. Although its physical state may change because of different amounts of energy, its atomic structure remains the same. So, what is a chemical change in matter? Let's start with a pure glass of water. If the formula of water were to change, that would be a chemical change. So, if you could add a second oxygen atom to water, you would have hydrogen peroxide. The molecules would not be water anymore. In reality, there are a variety of steps to go through to creating a hydrogen peroxide from water. Physical change related to changes in the immediate environment, such as temperature, pressure, and other forces. Chemical changes occur when the bonds between atoms in a compound are created or destroyed. Generally, the basic chemical structure does not change when there is a physical change. Of course, in extreme environments such as the sun, no molecule is safe from destruction. So we're going to make a compound this week, we'll talk more about that later. But we also will be looking at physical changes tomorrow. So we're going to take water and we're going to take H2O. We're going to say H2O. We take H2O and we're going to change it from a solid to a liquid to a gas. All right. And that's what I had to go turn off on the stove because I was fairly certain that that boiled way faster than I thought it was going to. So let's go to the next page and see what we got there. If we look at the states of matter, let's see. We look at the 5 states of matter on the site: solids, liquids, gases, plasmas, and the BEC are different states of matter that have different physical properties. Solids are often hard, liquids fill containers, and gases surround us in the air. Each of these states is also known as a phase. So these are different phases of matter. How does matter change from one state to another? All right, well, let's think about that for a second because we don't need experts to tell us why. It is the amount of heat or energy that when you force it into a system or when you remove it from a system. All right, so we'll look at that because I can't do it on here because it's the webcam. But when I do the video for tomorrow and I'm going to show you the different states, you'll see it better. That's about energy. Technically, it's the best way to understand it is about energy. For example, when the temperature of a system goes up, the matter in the system becomes more excited and active. So essentially, I have my temperature in my system of matter is just ginormous. If enough energy is pushed into a system, a phase change may occur as the matter moves to a more active state. Let's say you have a glass of water. When the temperature of the water goes up, the molecules get more excited and bounce around a lot more. If you give a liquid water molecule enough energy, it escapes its liquid phase and becomes a gas. The extra energy allows the molecules change to exist. Have you ever noticed that you can smell a turkey dinner after it starts to heat up? As the energy of the molecules inside the turkey heat up, the gases escape. You're able to smell the volatile chemical compounds that are mixed into the air around you. It's about the physical. Phase describes the physical state of matter. All right, so let's just look at this real quick. Because this could be somewhat confusing. This looks a little bit easier. Solids. So you take solids, you add energy, it becomes a liquid. You add energy, it becomes a gas. You add energy, it becomes a plasma. See, that's pretty much how it works. This is the activity that I'd like you to do today. I need you, when you're changing the states of matter, I need you to look at the different ways. Rocks. So say you have a rock. Let's just use that as an example. You have a rock, it's solid. If you warm it up, it becomes lava, right? Liquid rock. If you warm it up enough, those molecules will separate enough where it becomes a gas. And then finally, if you add more energy than that, it becomes a plasma. That's how that works. I like you to be able to don't worry about plasma. Don't stress about plasma. Okay, I want you to be able to take and tell me either on a Google Doc, a piece of paper. Heck, you could actually use an Expo marker or dry erase marker on the mirror in your bathroom if you like to. And I want you to show me in picture form how to take water from ice to water, liquid water, to a gas as steam. So explain that to me, all right? You can use pictures, you can use words, whatever you like is fine with me. So here's this piece right here. So this right here, whoop, I want you to do that as your activity, okay? This right here. So you see that? I just highlighted everything you need to do that activity. And use this too, by the way. Put the word solid, put a line, put a picture. Up, put liquids, put a picture, put a line, boop, put that in. Keep going up until you get it finished. And Angel, I loved your activity, man. You did a great job last time around. Throw out, what is that, a shout out to Angel? Nice job, man. Good work. And Jalissa, those CNN 10 things, warm in my heart. Keep that up too, by the way, so I don't forget to say it. All right. The other thing that you need to worry about is what is called pressure. Now, when you put pressure into something, you can change the different states of matter. All right, so let's go ahead and look. Changing the pressure of a system is another way to create a physical change. If you place a glass of liquid water on a table and it just sits there, if you place a glass of water in a vacuum chamber and lower the pressure, you can begin to watch the water boil and the water molecules move to a gas phase. So if you release some of the pressure holding those molecules together, it will go into a gaseous form. When molecules move from one phase to another, they are still the same substance. So water is water no matter if it's ice or steam or liquid water. There is water vapor above a boiling pot of water. That vapor or gas can condense and become a drop of liquid water in cooler air. So if you add energy to it, it can become a gas. If you cool it down, it can condense. And that pretty much is the actual cycle of rain, of water, the water cycle, when we get to that point in a couple days. Or actually, probably a couple weeks, I'm not going to lie. So, because we usually do it for an hour every day, and we're only doing it for a little bit of time lately. So hopefully we can get back to school pretty soon. All right. So, on the other hand, a chemical change would build or break the chemical bonds in water. If you added carbon atom, you would create formaldehyde. If you added oxygen, you would create a hydrogen peroxide. Neither new compound is anything like the original water molecule. Generally, changes in the physical state do not lead to any chemical changes. We'll look at that. If you look at states of matter, a solid is like a ceramic bowl. The ocean is a liquid. Gas is inside the balloons, not the balloons themselves, all right? Because I looked at this example before I started teaching, and the actual like latex balloon or the rubber is not that's not a gas. The stuff that's inside that makes it expand what's inside, that is a gas. Everybody take a break, take a minute, and go like this. Now you feel your lungs expand and got a little bigger. That is a gas that you filled up your body with and expanded out. That was made to expand is a gas. Okay, so we're clear. Plasma is like on the sun. We ain't worried about plasma because I'm not burning my apartment down. Now, I think that probably gives us a good basic idea of what we're talking about today, but I'd really like to do one more, just at least brief understanding. We're going to do this for real, so there's no point in doing it on paper. One more maybe. Oh, here's the water cycle. As you can see, it evaporates into the clouds. Clouds get cool. Rain comes down. Rain goes back into big groups, evaporates, and does it again. Over and over and over and over and over again. So we're definitely not going to worry too much about that. That's something we'll go when we get into the meteorological unit. So as we can say, chemical changes to this is no changes. We're good. Melting, rust. Rust is another good one. We don't usually have very much rust around here. And I think we're good. Okay, the last thing I wanted to look at was this right here. When it comes to solids, the molecules and the atoms line up. And when they line up, it's much more, it's in a matrix and it stays very rigid. That's what makes it solid. Crystals are pretty much the same, as you can see there. Crystals are actually a very, very beautiful thing. All right, now about the liquid lab. This is the last little bit of education you need before we get this lab started. Liquids are a second state of matter we will talk about. Okay, the solids can maintain their shape. We've already talked about that as well. Okay, if you have different types of molecules dissolved in a liquid, it is called a solution. That is what we're looking at this week with the lab for the liquid lab robot. We are going to make a solution, and we're going to take a solution that has a lot of food coloring in it, a lot of concentrated food coloring, to a lesser degree each time in each tube. All right. When we look at that, we could see that the droplets of the liquid we're going to introduce into the system will diffuse into the rest of the liquid over time. So that will show you the space and the movement that liquid has that solids do not have. All right, so we will go ahead and look at ice, and we're also going to look at water with those two types of diffusion into a solution. As you can see here, solids are more compressed, liquids are a little bit less compressed, and gases are not very compressed at all. Molecules do like to stick together. All right, so that's the reason why when you put when you have a cup that's cold inside but it's warmer on the outside, the condensation on the outside of the cup will form into liquid instead of like a weird gaseous kind of thing. So molecules like to stick together. That's pretty much all you need to know about that one. So going back to the Chem for Kids, if you'd like to go to this website, the website's address is right here. Feel free to enjoy the rest of the pages on here. But just to review, what you have to know, there are 5 states of matter. We're only going to go over 3. All right, ready? Solids, liquids, gases. We are not going to compress things and take enough energy out to do a BEC. We are not going to do that. And we're also not going to make a plasma, which I do not want to burn my apartment down. So those are the other 2 states. Second, when we do the liquid lab, physical change. We're going to be going over physical changes as well, because you can change these these compounds or these elements, and you can make them into a liquid, a gas, or a solid. So we're going to go ahead and do the phase changes this week. Last but not least, we're going to be doing the liquid lab, which will show you the diffusion when it comes to when you add things to liquids, how they diffuse into a substance. Right? So it's the reason why we have the ability to make coffee and tea and Kool-Aid, especially Kool-Aid, because Kool-Aid is awesome. So there you go. That's the reason why when you put something into water like salt, it doesn't just float on the top. It actually diffuses throughout the liquid. So that is our week of labs. I try to keep this as small as possible. I'm sorry if it's a little bit longer. I'm excited about the week. I'm really super excited. I'm going to have to do all these videos. This is Sunday for me. So I'm going to do all the videos on one day so I make sure that I don't lose track of where I'm at when it comes to the experiments. So I'm excited about my week. Make sure that you get that assignment done where you're changing the states of matter. So you need to be able to do where you have a solid, then you add energy to a liquid, you add energy to a gas. You do not have to do the last 2, just those 3 in the middle is fine. Thank you very much. I will see you tomorrow. And I need to start playing ahead of time and finding that off button. If anybody has any questions, you know that my email address is on there. Please, 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 when you're done watching the video, comment. Unless you have a school iPad. If you have a school iPad, they have the comments turned off. I haven't gotten a chance to talk to Mr. Justin about having those turned back on because it is very important you be able to talk to your friends. So if you, as one of my students or another student, are trying to get in contact with somebody, and they're not commenting back, there's a chance that their iPad from the school is not allowing them to. So don't get upset about it. Contact me and I'll see what I can do about emailing them. Have a great day.